Kia ora. This question from the Working at Home sheet is another example of where we have to use de Moivre's theorem to find the roots of an equation. So we need to be working in polar form. The first step here is to take this complex number and to get that into polar form. So I'm going to do that using a quick sketch. We can see in here we've got a k and a root 3k. So this is a similar triangle to our basic special triangle of 1, root 3 and 2. What we've got here is a triangle where we've got k, root 3k and 2k. That means that the argument in here is still going to be pi on 3. And if we think about how that looks on the diagram, then very roughly what we're saying is the angle here is pi on 3, and we could be at any point on that line depending on the value of k, right? But the angle isn't uniquely pi on 3, it's also pi on 3 plus 2 pi plus 4 pi and so on. So when I go to write k plus root 3 ki, I'm going to write it as 2k cis pi on 3 plus 2n pi. Now we've done lots of these now, I feel like, so if you're not getting this step, please can you send me an email and we can maybe do a Google Meet or some one-on-one work somehow. What we've got now is we've turned this into polar form, and now we just need to work on the z cubed. So let z equal r cis theta. We've got r cis theta cubed is equal to this. This was a merit question, by the way. So r cubed cis 3 theta is equal to this. R cubed is equal to 2k, so r is equal to the cube root of 2k, and theta is equal to pi on 9 plus 2n pi on 3, right? So what I'm doing there is I'm just matching up the 3 theta with all of that. This is about the one time in maths where it's good to go backwards with equivalent fractions. So when you're figuring these out, it's faster to change that 2/3 into 6n pi on 9. And that makes it pretty fast. We're looking for 3 roots because we've got a cubic. So z1 will be this. It'll just be cis of pi on 9. So that's when n equals 0. The next one, z2, will be when n is 1. So it'll be 7 pi on 9. And the third one is when n is -1. So that will get me cis of -5 pi on 9. Now it's fine if you want to do n equals 2 here, you'll get cis of 13 pi on 9, which is the same thing. Okay, but I'd prefer it if you were keeping your arguments between pi and -pi. So there you go, one nice little short merit question. I'll have another one ready shortly.